VOC here. Yeah. So you open VOC Media Player. VLC. I don't know. It's available for almost any platform, and it also plays almost any video because it has all the codecs on board. Like I think every other media player, I think apart from MPlayer, uses the codecs from Windows or from Macintosh for reproducing videos. And so if you don't have the codec installed on your operating system, you can't play the video. VOC is different. VOC comes with all the codecs integrated. So this is why it plays most of the videos. And it has a lot of extra features that most people don't know. You could use VOC for streaming media from your computer to your television, and you can watch the stream on your screen. And you could do a lot of fancy things. But let's start with an easy one. So you go to aquí it's Spanish, so it says medio, and then it says abrir dispositivo de captura. In English, it might say open capture device. Yeah, it's like the 1, 2, 3, 4, 5, the 6th one from the top, and the shortcut is Control-C. Yeah, something appears.
Yeah.
Okay, so once you click it, you get a screen like this one, and I think if you have like a webcam connected, you could choose to record from your webcam, which might also come in handy if you want to use it for like documentation of your projects. But in this case, I will use escritorio or desktop. Yeah. Follow?
Oh, okay.
And then here where it says frame rate, I will put 30 frames per second. Which is a bit overkill, but hey, with 15 frames it doesn't seem to work always. So let's take 30. And then on the very bottom, where it says reproduce, I click and I say convert. Instead of reproducing, I choose convert video. Yeah?
Why is it not activated for me?
Yeah, I will show you my screen. So once I click on convert, it opens another window. And this gives me the options that I can choose for which video format I want. And what you want is the H.264, what we know as MPEG-4. And as audio, we use MP3. So this might be, like some guys have like a newer version where it looks different, but in the end, this is what you want. So you want H.264 and MP3 as audio. Yeah, and maybe the ones that don't have the same version, I can look it up and tell you how it works on your version. But it's just for you to know that this option exists, because most people, they install some shareware screen recorder, and most of them are full of viruses, and so I thought this might be helpful. And you tell it where you want to put it. And I had some problems with it, and so I had to go in the preferences. So if you go to the preferences, and then to entrada codecs, or input codecs, there's a place where you can tell it the folder where to store stuff to. Like this might not be necessary, maybe it just works first run. Like on Linux, it works for me without doing anything, but on Windows I have to tell it here the folder. And once you got this, you can just click play and it will record whatever you're doing on your screen. This is the way I did those videos that I showed you. And if you use Blender for cutting video, you have a completely open source free solution for making videos of your desktop.
Frame rate
30. Yeah. 30, which is kind of the standard for Big 4. Okay, so this was just like a short recommendation, and let's get down to SolidWorks / Fusion. So I'm prepared for SolidWorks, but I think you can follow along in Fusion. If you have any problems, let me know. And so in SolidWorks, we go to File, New, and then we choose Part, and click OK, and you should see something like this. In Fusion, it's very similar. Yeah. This is like the Fusion corner, right? You also Fusion? Yeah, if I had known, I'd done it in Fusion, but yeah. And did you all find the YouTube videos where you can see like the same thing that I'm doing here? If not, if you go to YouTube and you search for my name, Ferdinand Meyer, you will find one that has like a funny picture with like little dots. That's me. And if you click on this guy, then you should find also the first two videos. They're called Lego 1 and Lego 2. So my design task for today is to build a Lego brick, but infamous Lego brick. This is one tool we need, and the other one is a caliper. But I will help you with the measuring part. So I'm gonna start by just like trying to take you a bit the fear of SolidWorks or Fusion, because I know that this is always people are like, ooh, this looks complicated, and I will try to show you that it's actually not complicated at all. It's quite easy. So so we will do like a few, like maybe 5 to 10 models that we just throw away, and then we do one copper one, which is this one, and then I'll show you how to make it parametric if you have enough time. But this might be, well, it might take too long, but then you can just watch the video. So if you go to my page, you should see something like this, and then it's this video. You can just have it open in another window. It's gonna, yeah. But this is as soon as we start making the Lego piece. So for now, I just want you to like lose your respect. So and it's also going to help us in figuring out what's similar in Fusion. Yeah. So here's the Fusion corner, and here. You're SolidWorks, huh? So I come to you two guys for seeing what's working and whatnot. And so right now we have something like this in both programs. And in SolidWorks, I want you to go to Features. You see this one? There's like tabs on the top, and one of them says Features. In Fusion, it's called Create. Yeah? And in Create, you can There's one that is called Extrude. This would be the one that you want in Fusion, and in SolidWorks you want Extrude Boss Base. So both of them are called Extrude, which is kind of easy, no?
Except it's in German.
Oh, sorry. Yeah. So it's called, it's this one.
Okay.
Yeah. So as soon as you click this one, your screen is going to change a little bit. So suddenly, it might look different on yours. It might look like something like this, no? But try clicking your middle mouse button and moving your mouse. This should like move your 3D view. In Fusion, it's
Shift middle.
It's shift middle mouse for shift middle mouse. It's enough for the moment. Yes. And then I want you to select in SolidWorks. It asks you a question here. It tells you select a plane on which to sketch. And in Fusion, did you click on this already?
Yeah.
No, it says select sketch for profiles. Yeah. So you would have to click on this plane one.
You have to create first sketch.
Or maybe we have to create a sketch first. So sorry for the Fusion users. Instead of clicking on Extrude, you have to first make a sketch. On sketch, like the very first one. Yeah. And now you select one of the planes. You need a mouse. Does anybody have a mouse? So let's go back. Okay.
Yeah, and the next thing is I don't have a normal USB slot.
You don't have any stuff.
It's the new
Okay. Yeah, well, I guess. Finally, he doesn't have a USB slot.
But I can take
Okay, Arsenal?
I'm actually planning to work on my iPad Pro with a pen.
Forget it.
No?
Well, if you want to make your life difficult, you can continue. But why would you? It's like,
That's what you want to do, I guess, no?
well, we're designing something as complex as a Lego brick. And I swear that I'm like twice as fast with a mouse than you are with any other method. If you want to get something fancy, you should buy a 3D mouse. At BMW, I had a mouse that looked more like a joystick for like an aeroplane. That's good. And you have this one in your left hand and you have the normal mouse in your right hand. That's great. But I beat you with a mouse by twice the time, I'm sure. You can try. And there's people that are professional modelers in Maya that don't use a mouse. But they are very fit on their keyboard. So I don't know. But touchpad is it's just making your life unnecessarily difficult. Like I wouldn't know why. Like, yeah. And this is like very simple piece. So now imagine you're building something like a 3D printer. Crazy. Yeah. So So once we are at this step, we select the plane that we want to sketch on, which would be, in our case, let's just pick the top plane.
On sketch or on create?
On sketch with the plus button. And then you have to click on one of the shift with the mouse button.
And then you follow.
Oh, okay, it goes a bit slow because everybody has some different problems. Some are slow, some are faster. But yeah, so let's assume that we're all kind of at this step. And so Solidworks automatically reoriented your drawing plane to look perpendicular onto your sketch plane. This doesn't always happen. In some cases you have to do it manually. I will show you how. But right now, our XYZ is like this. And you only see like the X and Y. And up here you have all your drawing tools. And this is very similar in Fusion, I guess. And for the moment, start out by just sketching something crazy. Like take a line or take whatever you want and make something that is where the last point coincides with your first one. That you create like some kind of closed shape. Can be any shape you want. Yeah. Yeah, easy, no? So this is our first sketch, and we note a few things about it. Maybe, let's just go ahead, and I'll show you for the next one. So once you're finished with your sketch, like actually one important thing is to know whether you're in Sketch or in 3D mode. In Fusion you can tell because on the right top corner there's a button that says Stop Sketch, which means if this one is there, you're in the sketch right now. And in SolidWorks, it's this button up here. Can you see here, this one? It looks like a page folding or something. This is the one that says Leave Sketch. So if there's a Leave Sketch sign, it means that now you're in the sketch. But now we want to leave the sketch, so I click on this one. And since we were clicking on Extrude in the beginning, it now makes an Extrude feature. So it gives it a 3D volume. And somewhere here, you can see the depth, the proposed depth of the Extrude. You can change it by either changing the number here, with inputting a number, clicking on the errors. You can also drag this little arrow for making it more or less. So just give it some random value and click on the green button. Like there's always like a little green button, either up here or over here, which means, okay, finished, I'm done. And then you should see something like this. Okay. Yeah, you have to give it some distance here. Right, so into black a little thing. What do you escape? Okay. Once you finish, you got this thing button or this one? Right now, no. Yeah. Okay. You have to keep it, it's kind of similar, and you have to. Ah, no, sorry. Okay, you keep it, and here is. Okay. And so this is your extrude. For some reason. The way the surface is extruded. So you should be in the perfect cycle. And then if you make a sketch, and you draw a square, and do the sketch. It's hard design. Okay, everybody has some weird block? Yes, click on the start sketch. Oh, yeah, sorry. No, it's not one. Okay, great. Yeah. Okay. Yeah. So maybe just for showing you that this is the basic principle, I want you to click somewhere in the white so that nothing is selected. Then click on one of the surfaces of your object. I would recommend to use the top one. And then I will do it like in Solidworks. There's several ways for getting to the same aim. I could say I want to make a sketch, and once I'm finished with the sketch, I extrude it. If I clicked on extrude, it would know, hey, if you want to extrude something, you need a sketch first. So it would automatically take you to the sketch interface where you make your sketch. And once you finish your sketch, it will already extrude it. But the result is the same. In Fusion, you have to make a sketch. If you can't click on extrude and not have a sketch. So I will do it like the Fusion way, which is a bit longer. Like you could take the shortcut in SolidWorks. But for now, I will click on sketch, which is like on the second tab. In German, it's called Skizze. And so if you click on sketch, it started a new sketch, which I can tell by seeing like the leave sketch button. But it didn't reorient the sketching plane for me, which is kind of a bummer because I want to see perpendicular to what I'm working.
In Fusion it does.
In Fusion it does, yeah. And so I will tell you the one and only shortcut you need to know for SolidWorks, which is Control 8. So once I hit Control 8, it will automatically like reorient to my sketching plane. Yeah? And then we can just make another sketch, whatever you want. Maybe draw a circle. And then I would leave the sketch again. Same thing that we just did. Yeah, okay. Just, no. Don't use it.
No.
No.
So,
Yeah, now we don't want to get back. I think on this one. And you can get there with a little bit. So you can see. And like in Fusion and SolidWorks, they both have this little 3D navigator. Forget it, you don't need it. I never use it. So was Control 8. Okay, sorry. Oh. Okay, so once we have the sketch, we leave the sketch again. We click on the little arrow. Yeah. By the way, you can also double click in the blank space, which has the same result as leaving the sketch. So now we can see our sketch, and we should make sure that we have it selected. And then we could, for example, click on Extrude again. So I go back to Features and to Extrude, and I have the same interface for like where I can like change the size of my feature. Great, we have all, which is also fine. Mission controls, yeah. Yeah. Okay, then maybe we wait a second until everybody's at the same spot. Yes, no.
Shift.
Okay, so one short, very important thing. So whichever 3D program you use, the first three things you should learn is how to zoom, dolly, and pan. They're the three most important things. And zooming is obvious, no? And dolly is like rotating your model in 3D. And pan is like moving it parallel to your screen. So in Fusion, it's with shift, middle mouse button, you dolly. With control, middle mouse button, you pan. And with rotating the mouse button, you zoom. In Solidworks, you dolly with the middle mouse button, you zoom by rotating the mouse wheel, and you pan by holding control and moving. Control and middle mouse button is for panning. Like whichever CAD program you use, this will be the first three things you should learn. I can show you in FreeCAD. In FreeCAD, you can choose between various forms of navigation. But actually, FreeCAD is using the same way of 3D navigation in CAD here, which is my favorite one, because you can do zoom, dolly, and pan without the keyboard, just with the mouse. It's a bit tricky. So zoom is rotating the mouse wheel. And pan is just the middle mouse button, and dolly is holding the right mouse button, pushing the middle mouse button, and pushing the middle and left one at the same time, and then releasing the left one. No, it's the two of them at the same time, makes dolly. Dolly. Pan. No shift. You don't need shift.
Shift and right here. Just
give it a try. Try pushing both at the same time. Is it on? Yeah. If you release the left one, it goes to pan. And if you rotate the mouse button, it goes to zoom. You can choose between several different ones in your preferences. But this is my favorite one. Okay. Yeah, most CAD programs you need to push like Shift or Control or Alt for having all those three. But the CAD navigation allows you to do zoom, dolly, pan just with the right mouse button, just with the mouse, and you still have your right click. So it's like super duper. Okay, let's try another operation, which is cutting a hole into it. So I want you to click on any of the surfaces, and we make another sketch. If you're in SolidWorks, you could just immediately go to Feature, Extruded Cut. But you could also just go to Sketch and make a sketch. Control 8, so that you're looking at it from the perpendicular view. And then maybe you can draw a hexagon. Okay? And so once you're finished, we leave the sketch again. And since I didn't tell it what I want to do, I have to go to Features, Extruded Cut now. And then I use the middle mouse button for rotating my view a little bit, and it gives me like a preview of what it's going to do. And once I hit OK, it's going to make the cut. So then I have something like this. And then our Fusion, we have to find the right way for this. And there's one button you have to press, so you are So in Fusion, there's how to explain this? Like in Fusion, you have somewhere, like for Solidworks use, it doesn't matter. In Fusion, you have a little bar down here, and the second button from the right, from the left, says Look At. So if you are in the sketch, you can just click on this one, and it will
put you in the plane that you work.
So you choose the plane that you want to sketch on, which is this one, for example. And imagine for some reason you are outside of this, and you want to go back to the sketch. So you click on this one, and then you want to change
Which one is the extrude or is it
So now we did an extrude. I don't want to, so I can just delete this one. And then it keeps you the sketch. And just go to this one. And it makes the cut.
For extrusion.
If you want to subtract material, you have to do a particle. And if you want to add material, or no, actually don't. Extrude down, it makes a whole yeah, okay. Yeah, Fusion doesn't distinguish between adding material and subtracting material. It just figures out by itself. If you're going down, it's a cut. If you're going up, it's an extrude.
Okay. There is an option operation, and just you want to get on
yeah, you can actually choose from a drop-down where it is. It's good. Fusion is like very user-friendly in this respect. In SolidWorks, you have to be more specific on what you want to do, which saves you a lot of work in the end. So, like most of my time modeling in Fusion, I spent on trying to work tidily, because it makes it so easy that it's also very easy to make a mess. Okay, so this was the first time you made a sketch in SolidWorks, and we didn't constrain it, and we didn't do anything. You should never do this again. Okay? So let's start by closing this document and make a new one. So again, file new, part. Okay? New file. Yeah? And let's draw a square with 100 by 100 millimeters. Like 100 millimeters is more or less the size of my fingers when I do it like this. This is like 150, 100, and this is maybe 220 millimeters. It's kind of handy to know more or less how big your fingers are. 21. So yeah. If I could, I would put it onto my belt, but it's too big. I have a small one that I always have with me. Like you can buy some for jewelers, they're like half the size. Yeah. Okay, so I start by doing a sketch. If I was in Fusion, since I'm in SolidWorks, I just click on Extrude, Boss Extrude, and I select the top plane. So this time it's important to choose the top plane. Yeah? And this is something I want to spend a moment on putting importance on this topic. Whenever you work in any of those CAD programs, you should know where the front is of your part. Yeah? Sounds stupid, and I won't go into the deep explanations of it, but you should know where's top, where's front, where's side view. So for a telephone, where's the front view?
Screen.
If you put it on the table, the front view would be this one, no? And this is the top view. So sometimes, but I would say this is the top view, right? And the front view is this one. For giving you an example, for example, most cars, their origin is, it's Yeah, in the beginning you should think about where's my front right top and where's the center of it, where's my coordinate system. So all cars, their coordinate system is in the middle between the front wheels. This is where the axle meets of the front wheels, this is the middle of your car. And the middle of the motor is where cylinder 1 meets your crankshaft. The center of your cylinder head is where the combustion chamber plane meets your cylinder 1 axis. It's just like conventions, but you should make a mini convention for yourself and stick to it. So this is why this first click is kind of important, because it defines more or less where front, top, left, right of your model is. So spend like 2 seconds on being like where's top? And makes a lot of sense that this is top, and this is front, and this is right. But it depends on where you place the object. Yeah, but most objects, like mostly once you know it for yourself, it's enough. But yeah, like I will spare you the details, but you will remember me at some point. Okay, so I take my top plane and I click on I draw a rectangle where the bottom left corner coincides with my origin. So if I hover over the origin, there's like a little point appearing, which means that the sketcher is proposing, hey, do you want to put a constraint there? A constraint is one of those conditions that I can give to my geometry. And a coincidence constraint is one that says that 2 points coincide there at the same location. So Solidworks showing me this little yellow dot here means that it's proposing to make a coincident constraint. And this is what I'm going to do. So I just click once and click another time, and I have my square. Yeah?
And why do you draw from like upright?
You could do it bottom down as well.
Okay.
It was just easier to explain that you have to look out.
Yeah. You're using a constant.
Yeah.
Coincident.
Yeah. And once you're finished, I want you to click Escape. Yeah. So you see that my changed very little, but now I can actually click on lines which I couldn't before. Give it a try. Should be very similar. No? Yeah. That's the same. Try moving those lines around. Just click on them and drag them. So you should be able to resize them. At least the 2 ones that are not, like the ones here, I can't move them because they're coincident with the origin. They're locked. And you can also tell that those 2 lines are blue, while the other ones are black. So blue line means under constraint. Under constraint means it's not, if you wanted to give this to manufacturing, they would miss information. They couldn't manufacture it because you're missing dimensions or constraints.
Can you explain what does it mean coincident constraint? So
coincident means 2 points at the same location or 2 lines at the same position. Coincide is like be in the same spot.
And why do you use it here?
I'll explain it in a moment. For the moment, don't worry. But be happy that you just made your first constraint. It's like.
But wait. Fusion works a little bit different.
Yeah. The fusion also does it on right.
I mean, it's usually created on this rectangle.
Yeah. And now you didn't click exactly on the middle, so it didn't get a constraint. Yeah. You see that it makes this little blue square. Yeah. It means that it's proposing a constraint.
Okay. And I would give a constraint here if you want to see.
Yeah.
And here this is.
Yeah. Okay. So in Fusion, it always shows you like a little blue square when it's kind of proposing a constraint, whereas in SolidWorks it shows you like a little symbol.
But it's more like a thing, no? It's more like
it's not snapping, no. It's more intelligent than snapping.
But is it go with the grid? The constraint?
No, nothing with the grid.
But it doesn't only constrain on the grid area.
No. It constrains on your origin, which is by chance in the middle of your grid. Okay, so now we want to put another two constraints, which are dimensions. So a dimension is another constraint. It's constraining our geometry. So in Solidworks, you click here on Smart Dimension oder intelligente Bemaßung. Yeah, and in Fusion it's oh, where is it?
I think it's when you click on sketch and then you just sketch dimension, you get D.
G. Yes. And where is it hidden? Here, sketch. Why does it not? I think you left the sketch. Yeah.
Is that it? Sketch dimension. Yeah.
Okay, so just 1 second, I'll go around and make sure that everybody catches up. And so in SolidWorks, you would click on the line, and you can see that. Can you see this little yellow dot popping up? Yeah. Don't click on the yellow dot. Click somewhere else, but on the line. Click once, and then click another time for dropping the dimension, and then type 100. And hit enter, and then the same thing for the other side.
Is it 100 we want? 100 by 100?
Yeah, 100 by 100. Yeah. Try moving those dimensions a bit away from the line so you can actually see them.
So I'm good. I have it, but now I don't see
Yes,
it.
you left the sketch, so if you want to go back to the sketch, you start on this one. So now it says start sketch again, and you're back in here, and you want 100 by 100. Yes. No. Yeah.
And then you just go and
Yeah. So you left the sketch. So you go back here to the sketch. And then you go. Sorry. And you're also the sketch. Okay, everybody? Easy, no? Okay, so I changed my mind. I want it to be 100 by 50. And I want the 100 to be 100 wide and 50 high. So probably you can just double click on your dimension, input another number, and you should get something that is 100 by 50. And this is the beautiful thing. This is what we call associative. So if you change a dimension, it will change your geometry, which is wonderful. Like in Rhino, you would have to delete everything and draw a new square. Here you can just say, hey, no, I changed my mind. I want it to be 50. Double click on this one. Awesome. Okay. And now let's leave the sketch by clicking on the top right arrow. And I want it to be 20 high. Then I click on the green one. And you should have something like this, no?
So you go to extrude.
Yeah, in Fusion you have to go to Extrude first, yeah? Just, yeah. Yeah. And then this one, and you have in 20. Okay, surprise, I changed my mind again. I don't want it to be 20 high, I want it to be 10 high. So I will explain it first for Solidworks, and then I will explain it for Fusion. So in Solidworks, you can see that on the left side, there's like a tree of all your features. So our extrude is a feature. And this feature has a 2D geometry associated to it. And for seeing the 2D geometry, we have to click on this little arrow so we see our sketch. And if you click on the sketch, you can right-click, and then on the top left one, there's a little button that says Edit Sketch. There's quicker ways of getting there, but basically this is the one. And in Fusion, you also, it looks very similar. You see also a sketch, and I think you just double-click it. You double-click on the little picture. Yeah. Ah! Okay. Yeah, I'm sorry. Actually, I did something wrong. I don't want you to edit the sketch, but I want you to edit the feature. So I don't click on Edit Sketch, but I click on the feature, and I right-click, and I say Edit Feature. Also the top left one.
What's the name of the feature?
The name of it?
The feature? Like, you have to click on the feature.
You basically have bodies and body one. Double-click. Also. I want to edit the feature.
The extrude?
Yeah.
Then you have to click on the stick to get
Yeah. In Fusion, you click on, there's like a history line on the bottom, and the last one you see is the result. If you double click on this one, it takes you back to the same dialog that you had before.
You can right click and there's a digit feature.
Yeah.
The last one, right.
So now, click on feature, and then on feature bar. Then you can change it to one. I want it to be 10 high. Font? Okay. Then let's do another sketch. In this case, in Fusion, you would just make a sketch and then we make it a cut. In SolidWorks, you could either make first a sketch or you click directly on this one, Extruded Cut. And then you click on the surface that you want to sketch on. Control 8 for looking on it perpendicularly. As I said, there's many ways of doing it. You could select the plane first and then click on Cut, or you could click on Cut and then select on the plane. It's whichever way around suits you best. And in Fusion, you just click on the top plane and you click on this little one here. Look at it. And then you draw a circle. And I want a 10 millimeter diameter circle, and I want it to be 20 millimeters from the top and from the left edge. To quickly show you.
Yeah.
So I click on the left edge, and then I click on the center of the circle, which is going to allow me to give a dimension, which is going to be 20. And I do the same for the top edge, and this is also 20. And then I click on the line itself, and I tell it to be 10.
The center of the circle.
Yeah.
And where we were, what's the top line? And the circle itself was 10?
Yeah.
Because you put it anywhere.
Yeah. And then let's sketch dimension. First, I do the diameter, which is 10. You don't have to put millimeters, it kind of knows. Then I click on this one, and then on the circle, which gives me this one, which is also 10. And And then on the top one and this one, somehow your squares will be in line. Yes, you did already. Yeah, that's good. And then I'll click on the stage. Are you?
And instead of
Yeah, it's not, it's doing the thing again.
Thank you.
It's not doing what it's supposed to be doing.
It's a profound use this never ever. Okay, like slowly we're running out of time. Actually, I wanted to finish this exercise. Yeah, let's finish this one first, and then we can continue. Okay, so I say okay, and now if we look. This is another thing. It's okay. That doesn't matter for the moment. But you can leave the sketch up and make this one and cut it over. So you can with cutting a hole. So so once we're leaving, we get to the side log where we can choose the depth that we want to cut. And you see that I have a choice between, there's like a drop down where it says blind. And blind means it's a hole where we define the depth of it. But I want a hole that goes all the way through. So I click on blind and I say through all. So it's going to cut a hole until there's nothing more to cut. And I click the green hook, and now we should have our plate with a hole. Yeah, there's where it says distance, you click on it, and you say instead of distance, you say through all. Yeah, there's separation.
Ah, yes. But it's is it now or? Particular constraint?
Yeah, I need to find out how, but I can. It's very
Okay, well.
So now I want you to save this file somewhere. So please save your file somewhere where you know where it is. And so usually I save my files all, like everything that belongs to one project, I save it into the same folder.
Yeah, but there in this case it saves on Fusion.
Yeah, in Fusion you just hit save.
And then you use it for the master,
Yeah.
and that's it.
And it's like without.
Yeah.
Yeah. Very,
Okay, and once we are at this point, we make a new file. Yeah. So you go to File, New, Part, and in Fusion this is very similar. Yeah. Okay. And this time I want to make a revolve feature. So I click on Revolved Boss Base. In Fusion, I guess you make a sketch first.
The previous one that we were building was a Lego brick. So what is this?
We're not at the Lego brick yet. We're just fooling around.
Ah, so it's like,
yeah, we do a rectangle, we do a circle, we do
wait a second. So everybody has, like Fusion, you click on make a new sketch. And Solidworks, you click on Revolved Boss Base. And you pick the front plane, in both cases, for placing your sketch. And in SolidWorks, I want you to click on the line feature, but on the little triangle next to it where it says center line. It's hidden under, yeah, center line. And I want you to draw a line that goes exactly through the origin. And if you move your mouse like close to the origin, you see that it draws like a dotted line, which is kind of proposing us, hey, you want a line that goes through the middle? And I want, so I just click once here, and I move up, and at some point it shows me this little icon this one, which means it's proposing a constraint that is vertical. And yes, I want it to be vertical, so I click when this little symbol appears, and then I double click, which means I want to finish. And in Fusion, and we just draw a line, a vertical line for the moment.
like solid
No, you go a bit under the origin. Yeah. It doesn't matter. It doesn't matter. Just,
A little bit under the origin.
and a little bit over. Yeah.
And no matter what.
Yeah. Then you double click for finishing, or hit escape or something. Yeah. Escape. Yeah. And I think in Fusion, if you draw too much, you can just select it and leave it. Select. And if you try something. So in Fusion, if you right-click on your line, there's a little pop-up menu coming, and there's one that is, the bottom one is called Sketch, and you go to the fourth item that says Normal Construction. So any line you draw, you can toggle it between being a construction line, which is kind of it's just a helping geometry for you, but it's nothing that is going to create geometry. So we want to draw like a helper line, like the center line that we made in Solidworks.
You can do it in sketch palette, it's much more easier, it's less steps. So you have the sketch palette on the right bottom side, and then there's options, and there's
Yeah, actually there's like a pop-up thing on the side where you can choose the same.
What is it when you choose to do the
If this was an extrude, and you would tell it to, if you drew like a square, and you wanted to extrude it, it would say there's no geometry. It's just like a sketch line. It doesn't interfere with your normal geometry.
So which one should be actually
You want? No, you already. You already chose the lines. Okay. As long as you keep talking, I keep thinking that something's wrong. This is the vertical constraint. It's good that you have it. And now you want the normal construction. Okay. So let us quickly have a look at what we're seeing here, because I can tell that there's some confusion about it. And actually, I'm not seeing something here that I want to see. So I have to go to View. Oh, come on. So if your SolidWorks window looks like mine, where you just see the line, nothing else, then you want to go to View, Hide Show, and Sketch Relations. Yeah? This is just for the SolidWorks users. The Fusion users, they should see like a little funny symbol on top of their center. This little thing. It's your constraint. Yeah. So as soon as I click here on Sketch Relations, I see two ones. You see these little green things? You want to see those. That's important. That's just as important as the geometry. And so this one is a constraint that says this line is vertical. And this one is a constraint that says my line coincides with the origin of my coordinate system. If you want, you could, like if I delete this one, like right now I can't, my line doesn't move in left or right. If I delete this one, don't do it, don't do it please, then I can move it, yeah? It's still going, it's always going through the origin because the other constraint is still there, but this kind of limits it to be always vertical. Okay? Yeah? And give me a second, maybe I'll answer your question. So I want you to use the line tool and draw something like this. Okay, as bad as it looks, but that's on purpose. Yeah? Please draw it on this. Yeah, actually. try to draw it on the same side of the line I did.
On the same sketch.
No. Look at my screen. I'm on the right side and on the top sector.
So it should be a new sketch, right?
No, we're still in the same sketch. And I want, like, if this is my coordinate system, I want you to draw in this area here. Not here, not here, not here. Yeah, and you will see it. Actually, I don't want to need it actually. I want this one to be a reflection. And I've done this at the beginning by choosing here and now
First one is a circle, very blue. And second constraint is meaning looks like all the way
Okay. Can I have your attention for a second? So if you look at our model, we see that there's that a few constraints have been created automatically. So it kind of figured out that I want this line to be horizontal and this one to be vertical. And this one also looks quite horizontal. If I want to select those lines, I hit Escape, so I can just click on them. And actually I want this line also to be horizontal. If I click on it, there's like this pop-up appearing, and it kind of recommends me constraints that I could give to this line. And I click on horizontal. And you see that it adds the horizontal constraint, and it makes the line horizontal. In Fusion, you have this pop-up thing where you can just select a line. For example, I want this one to be horizontal as well. And same thing works for this one to be vertical, and this one to be horizontal. So with a few clicks, you should get your thing to be more or less orthogonal. Yeah, because you see all these other constraints, they're all variable constraints.
You made them.
You made them automatically.
Yeah. So you can.
Yeah, if you write any constraint,
Yes.
you can also do this one. You could also keep it. But yeah, basically what we want is somewhere here or equal. Yeah, or right click as always as one. It is kind of the same. We want to make it somewhat like mine, very roughly.
wait, so something have to think.
Each sketch shows that there are these ones are true.
Yours is vertical, and then you can see the variables. It's a semi-top.
Yeah, okay.
But in my case, if I try to change it,
Yeah. But it should make a difference because your left line is vertical and the other one is
Yeah,
vertical.
but if you take this one out and you take this out, then you can hold it.
Okay, so just like a little explanation. So, for example, Isaac, he has, instead of telling, well, we know that this line is vertical. That's what we told it right in the beginning. And so if I made this line parallel to this one, it would be vertical. It would have the same effect, which is okay. So you can have different things leading to the same result. In this case, it doesn't matter. But you should get used to sometimes just deleting those constraints if you want them different. So in Fusion and in Solidworks, you can just click on them and delete them and make new ones. It's nothing tragic. It's not changing anything dramatically. Okay? So you can see that my lines are still all blue, and I can still just move them around because I haven't properly constrained it yet. But I will save. Actually, I'll show you two things. The first one is how to make a diameter dimension. So I go to Smart Dimension. I click on the center line. I click on one of the lines, and then I move my mouse on the other side of the center line. And you see what happens? It jumps from a radius dimension to a diameter dimension. To be honest, I have no idea how this works in Fusion. It should be something similar. Try clicking on the center line again. Escape. And dimension is below. Yeah. In Fusion, let's right click and say diameter dimension. Oh, then make it yeah. Okay. So now it's right. And you say diameter dimension.
Mine is doing now what it was meant to do before. Like now does the incorrect. Ah,
That's it.
what was it? I'm sorry. What direction should we put in?
Whatever. Just leave whatever is here. We're going to change this in a second. Okay, and so once you're at this point, like normally you should continue until all your lines are black, until it's fully constrained. But since we're like running out of time, well, I don't know how constrained are you in times? Like the original idea was to continue till 7. I can continue longer if you want. Should we aim at 7 or at 8?
Like 9 and 8, yeah.
Yeah? Okay. Maybe we try to finish this exercise till 7, which is in half an hour. And then we make a little break, and then we continue with the Lego piece. Who wants. Yeah? Okay. So once we're at this point, we leave the sketch.
I missed the last.
Y entonces la ve ahí. Vale, porque toque aquí.
change. So maybe like I'm sorry for looking so clumsy when I'm showing you Fusion. Just for like CAD programs are kind of my hobby, and so when Fusion came out, of course I had to try it. And so the first thing I did, I modeled this machine. I don't know if you like. It's a little CNC mill like the Shopbot, and you can now I'm using Fusion A380, which is like the online version of Fusion, so you can see your models in the browser. So I modeled this from scratch by like taking measurements on the machine. I took maybe 50 photographs of the machine, wrote a whole lot of dimensions on paper, and then remodeled the whole machine.
You've done that?
Yeah. And this is kind of the, I kind of reached the limit of complexity that Fusion can accept. So in the end, I was getting like weird things, like suddenly this whole assembly of the belt thing would jump in the middle. And then when I click on it, it would jump back. So Fusion is full of these little bugs that, like, I didn't do anything wrong. It's just that Fusion freaked out on me because I had too many parts. It's not used to working with, and this is still a very simple machine. Like it has a lot of parts, but like if you look inside, I have all the, like here's all the stepper motors and all the bearings. Like it's not terribly complicated, but it's complicated enough for making Fusion freak out. So sorry for looking like an idiot trying to explain you Fusion, but believe me, I know Fusion better than I want to. Because like for getting to this result, you have to like start over again and try better. And
you cannot export it and import it somewhere else?
Yeah, I could export this. I could export it as a step file, but which makes it stupid. Like right now I have it intelligent, so I could tell it to use a different profile, or like it still has all the dimensions in there. If I export it in step, I would lose them. Yeah, but that's kind of the same with all CAD programs. There's not a single one where you can export from, maybe between Inventor and no, maybe between Katya and, no, not even between Katya and SolidWorks can you properly export pieces. Yeah. So
what makes it crash as an algorithm?
It's a young program. It's like 2 or 3 years old. Like as I told you, like when Katya was 20 years old, when Pro Engineer was 20 years old, Katya was only 10 years old, and you could feel the difference. It's like it took another 10 years for Katya to catch up, and they had like tons of developers working full time on this. And this is what Fusion is doing right now. But it's going to take another 10 years until Fusion is where the others have been 10 years ago. But what Fusion is trying is very, it's, there's some things that I absolutely don't like. For example, but maybe we stumble upon one of those. But it's too easy on you. It allows you to do a lot of little, not exactly mistakes, but things that are not clean. And those unclean things accumulate very quickly. And this is probably also why it crashes. So yeah, so I had to go back and work cleaner by working the same way I would work in SolidWorks, because I know it needs this information. One of the typical things was, in Fusion you can make a plane, and your plane is just there, but it doesn't have a front or a back side. In Pro Engineer, whenever you create a plane, you say this is front, this is back. And what would usually happen is that at some point the plane would forget which way round it is, and all your features would like flip from one side to the other, which you can imagine is incredibly annoying. And yeah, so it's stuff like this, which it seems to be easy first because you skip one step, but in the end it bites you in the ass because your model suddenly flips inside out. Okay, so back to SolidWorks. I accept I leave my sketch, and it's going to create a ring. So it takes the sketch and it revolves it around. Isaac, can we try to not speak at the same time? Like, if you have something to say, like, let me know and I'll shut up. But like, if you all talk at the same time, it doesn't work. Do you have something like this? Yeah. That's all good. So it's stop sketch. And in Fusion, we have to click on your sketch, and then click on Create, Revolve. And it asks you for the profile, which we select. Then it asks for the axis, and this is where we take our line. And then we have to hit Shift and Shift in the mouse button. Shift. Shift. And with the mouse button, and move your mouse button. Yes?
Wait, can I repeat it?
And then you open the solution, it's not sketch. You open the sketch. It's not so you can just and it's still set. Now you click on the sketch. Remove this one. Like you could tell it to not do a full circle, but only like 180 degrees, or you just take like a piece of pie. Maybe still in national. Actually, don't play still national. This is our this is a solid. Finish this operation. You see that okay. Can you use it?
I'm trying to get a fresh air.
Here's how I think
I am just in there.
yeah. Well, Fricad is like if Solidworks is if Fusion is super easy, Solidworks is a bit more complicated, and Fricad is a little bit more complicated. But it's but the steps are the same.
Yeah.
Okay, so I click on the green one, and I have my part finished. And now I want you to make a new file. This time, we save this one. So Control S, and I save it in the same folder where I have my other part. Actually, I haven't saved anything yet, so I should. Yeah, another thing in Fusion and in Solidworks, you switch between windows by clicking Control Tab. Can you see what happens on my screen? So if you hit, if you just want to go back to the last file you had open, you click Control Tab and it goes back to the last one. If you want to go back to the file that it's like in your browser, Like if you want to go to the pen ultimate file that you used, you hit Control Tab. Or you actually look and you click Tab as many times as you need for getting to the respective file. This should work in Fricad as well. Okay, so once we saved both our files, we click on we click on File New, and this time we choose Assembly. And in Fusion, I think it doesn't really matter. You just make a new file. Yeah. And work with you.
Well, I don't know.
Yeah, all of it. Okay, more or less. So,
Well, no, it's the visualization version. So it's for you show it to the client. So you can say, okay, to put it in, and you post it in, but not for the rest.
okay, all the Fusion users have a new file, and all the Solidworks users see something like this. Actually, I can tell that this is not really displaying my whole screen. I will do something. That's better, no? Yeah. Okay, and so you see it says insert component, right? Componente. Yeah. So, just watch this. Like Fusion users for the moment don't do anything, and SolidWorks users pay attention. So it shows you here like the last two parts that are open in our session. And if you click on one of them and you move your mouse in the 3D view, it shows you a preview. And now don't do anything, please. If I would click now, it would position the part at the current location of where I click. It's like really important. It's like the most important thing I will ever tell you for both programs. Yeah. So I don't want you to click now. I want you to move your mouse back out and click on this little green thing. What this does, it positions our part so that the origin of the part is in the same location than the origin of the assembly. Easy, no? If I click somewhere, it positions it somewhere in 3D space. And it's away from my origin, and suddenly nothing fits anymore. Like, you could fix this by aligning the X, Y, and Z planes to each other, but that's a lot more work than just clicking on the green button. Yeah? So now I can see that there's an assembly, and there's an X, Y, Z plane for the assembly, and inside there's my part, and the X, Y, Z plane are the same then for my assembly. Okay? You looking a bit skeptic?
What do you mean by assembly?
Assembly is like, let's say you're building a car, so the motor would be one part, and the motor together with the rest of the car would be an assembly of the two things. An assembly is like a conjunction of pieces. And normally, everything that is separable, like this would be an assembly of 1, 2, 3, 4, 5 pieces, where the little ball in the middle would be one of the pieces. Sometimes you have pieces where it's hard to say whether it's an assembly or not. For example, you know those toothbrushes that are like half rubber, half plastic? Is this an assembly or is it a part? But most of the time you can clearly say, I can disconnect them, so now I have an assembly. Yeah? So most of the time you're fine drawing each part separately and then assembling them to an assembly. And so this is fine for the moment. And so now we have an assembly with just one part. And now we want to put a second part. And so I click on Insert Component for the SolidWorks users. I will explain the whole thing for Fusion in a second. And it gives me the same file dialog. And this time I click on the other part. And now I can just click anywhere I want. Okay? This time, yes. It's only the very first time where you want to position it in the origin. Okay. And for Fusion, I think I have to change here for model. Assemble. So in Assemble, you click on New Component. Right next to Modify and Create, there's a button Assemble. And if you click on this one,
and you assume that you create a component from scratch here.
yeah, which is not what I want. I want to just put a new. I think I remember. There was some way of like getting to like a view where I see my other parts. Huh? But if I had known that it was a fusion course, I would have had another look at this.
You right click so you open up the project pane, you right click on the component that you model, and you click on insert with your current design.
Yeah, this is what I was searching for. Where is it?
So that's when you
yeah, this one. Okay, so on the very top left corner, there's like a symbol with like 9 little squares. And if you click on this one, it shows you all your components, and you can just drag and drop them into your.
No, it's not drag and drop.
When you right click and you say insert into. Yeah. You have to save it first.
Oh, I have to so try to do it, and let's hear us. Is this not how you hit?
No, I have
Yeah. I was for so it means it. Okay. And once you have how you fix the others,
this is one of the things that are there should be a constraint to this. I forgot, but I think so. Yeah, probably it's automatically fixing it without telling you or something. It's doing too much for you sometimes. This one try to move it a bit away. Click on the right things to move it into space. Yeah.
I'm trying to find my folder.
Yeah. Okay, so I'll quickly explain the Solidworks solution, and then I show the Fusion one. It's a bit different in this case, but yeah. So all the Solidworks users are present, yeah. Okay. So if you left click on a part, you can drag it around, and if you middle click, you can move to a view where this kind of makes sense. And if you right click on a part, you can turn it. Yeah? Like this. This is only true for SolidWorks. And so I would like to stick this part into this hole, which obviously is far too big, but right now we don't really care. So I'm going to go and I'm going to select the outer surface of this one. First I rotate it a little bit in the direction where I want it to be. So try right clicking on this one and turn it. Yes, okay, that's good enough. And now then turn it around so you can actually see where you're clicking, and click on this surface. No, no. Actually, it doesn't matter. But, yeah. And now, please control click onto the hole. And once you release the control button, there's this little pop-up menu. There's different ways of getting to the constraints in 3D, but this works quite well for me. Like there's also actually I don't even know how to get to the normal, like what you want is to establish a mate condition. So the constraints in 3D, they're called mates, but basically it's constraints as well. And I want to use a concentric constraint. So it's a symbol with like two circles. And once I click this, it should have oriented. Wait, I have to do it again. For some reason it didn't work. What the hell? Huh? Okay, somehow my assembly is weird. Let me try again. Okay, so for the works for you now, you can try like moving your disc up and down. You can rotate it, you can move it up and down, but you can't move it out of axis from the hole. And so for the fusion users, okay. And so I want this middle to be this middle. And I move it on there. So you turn it up. And you take there. Yeah, that works. Yeah, it shows you that like this is fixed, this is fixed, this is fixed. Like fusion it kind of wiggles around like very fixed. Okay. And so now we see, okay, our revolve is too big. Like we won't fit this into the hole. So we have to edit our revolve. But first I want to know how big is this hole. I think it was 10 now. Okay? So I control tab until I get to my part 4, or whatever yours is called. And I open I go to the sketch in the tree, and I click on Edit Sketch. And in Fusion, I think you just open here and double click on Sketch. Now you go to your whichever one you got. Yes. Then you double click this. What is the first one? Double click on the first one. Double click? No, on the first. Okay, and so now we need a dimension. So I hit my Control 8 again, so I can actually see what's going on. And I want a dimension that goes from what happened here? Sorry, something's wrong. For some reason I don't see my sketch. Oh yeah. So since all our lines are blue, I can just move them around. So I will start by making the whole thing a bit smaller. So I can just click and drag. Now this one, this is the dimension we wanted, and we want it to be 20, no? And the rest I just move it by hand so that it doesn't overlap the center line, and then so it looks a bit more like. Which dimension is 20? Looks a bit nicer. Sorry? Which dimension is 20? This one will be faster, but it's not. Now you have to move those back. Yes, you can pick this one, and then probably Command pick this one, and then tell it to constraint.
Can you constrain the dimension depending on the component?
Yes, yeah, we will do this in a second.
But why not, like, every time I hit here, it's
So we make sure that we repeat the sketch. We have to save those elements. Yes. I don't have to and so now we can make content. Yeah. So you want to get there, huh? And please, no. You have to go to the file, which is control, until you get to the part. And here, sketch. So this one I have to I go to the sketch, and edit the sketch, and then this one I can just scan Now, it looks like we didn't have the constraint between this one and this one. So I can select this one, and then shift select this one. And then I click on consent. then you need to save it.
I'm sure in this book is a certain here we have allowings and
Everything is the
okay.
All of you. Yeah. It's working. So you want to I don't know if I could.
And you change the dimension of your application and you go to the sketch and you double click.
Now, this is like it.
And
So
then
you
you
change this dimension.
no, this is the inner one because we don't need it. And we want to move it closer already. So if it's supposed to fit into the hole, then we must dimension this one now. So I go to D for dimensions. Then I want dimension from. If you already have something selected, then it will already start dimensioning from this one. So I go from this one to this one. And since I don't know how to make the diameter dimension in Fusion, I just make it 5 instead of 10. I need to make sure that it doesn't cross over the outside of the fabric. And then you can adjust it.
But it does not do more beside it.
No.
So now there will be 5 on this side and 5 on this side.
Yeah, which is 10. So this is the radius. Sketch. Now we go to where's the same ratio?
It's 0.
Oh,
Yeah,
yeah.
this one's the other. Yeah, go ahead.
And here you have to click and say, I think there was a way of doing this automatically. Oh, we didn't save, so we have to go back to this one. And say, you have to click on the menu and here.
Okay, then he's going to bring it to the assembly.
Which is kind of unnecessary. I'm sure that there's like an auto update option.
Okay, so the piece that is not assembled, when you edit it here, and you tell him you apply the change to it.
Yeah. So now it should fit.
Okay, I understand, because you wanted to fit the, okay, I thought you wanted to fit the interior diameters. Okay, es que él quiere, ese es este diámetro.
So we make this one.
Okay. And then you see that.
And make sure that it doesn't cross the center line.
And you leave a hole there.
If you make it coincide with the center line, you get something that doesn't have a line. Yeah. And you save it, and then you go to the assembly, and then you have to right click and you can print it. If you also right click and you say this version 5. Probably running on that.
I think it's working. Since I don't maybe it's okay.
And this is already the right diameter.
Yeah. Okay.
Yeah, you right click and Almost overlapping. Actually, this overlapping. I think there's an also updated option somewhere. It's just that it's already used before. More than a year ago. So you don't have to escape data. This is ridiculous. I wouldn't have a problem with that. Oh, that's the next. Didn't save we saved while it was still in the sketch. Yes, good night. Okay, yeah. So let's do one last step, then we can have a little break. So right now our piece is in the right hole. Oh, mine is still wrong. Well, it doesn't matter. So I'll show you in Solidworks, and then we'll figure out how to do it in Fusion. So like actually, if you click here on Mate, you can see all the different mates that you can have. This is true for Fusion and for Solidworks. So we can have the coincident, which is like two faces touching each other. They always have an option where you can flip one of them. So it could touch like this, or it could touch like this. This is just an option you have. Then you have parallel, which you can place them anywhere like this, but you can't place them like this. The two faces will always stay parallel, but you can still change the distance. Then you have perpendicular, which would make it like right angle to each other. Tangent, which would make a circle stick to a plane, for example. Then concentric, which is the one that we just used. Lock, which would just lock it in place, which you hardly ever use, only for the very first piece. And then you have a distance constraint and an angle constraint. So let's say you want two pieces to fit together but have a little distance, then you would give it the basically the distance constraint is like a coincident constraint or like a parallel constraint together with a dimension. So you could either use this through this menu, or you can just click on the pieces. So I would click on the lower rim of this one, and on the upper surface of this one, and then click on coincident, which would drop it on there.
Oh, it's animated.
Wow! The first time I did this, I was so happy, like woo! And so the problem is like right now they're fixed, so I can't move anything anymore. And if I want it, I can see down here is all my mates, and I could go to the last mate and edit it. If I see it, and I could say, you know what? I don't want it to be coincident, but I want it to be with a dimension. And now I could type in 50, and it would move it up. Or I say, no, actually I wanted 1 millimeter, and it would move it down again. So this is the way you could like control the distance of how those pieces are assembled. You see, now I have a millimeter of distance between them. In Fusion, Fusion has these super constraints. It's like one of these, it's this little thing, and it can do the two things at the same time. So in Fusion, if you place this little dot in the middle, this dot can flip. So it can do like a concentric and a coincident at the same time, which is kind of nice if you want to quickly assemble lots of pieces, but quite annoying if you want to like know what you're doing exactly. So in Fusion, to be honest, you would do it with the very first constraint if you could, but luckily you should be able to see the constraints. So kind of, I would have to make that one, and I will put it right here, which is the base of the thing, and make this one. No, we'll make this one coincide. And then once I hit this one, it's asking, and I say capture position, but I have it comes back. And I take this one. Now I can put the one. For getting a little distance on the unit, which it didn't do. No, it didn't. But try again. Try doing this one. And let's try again. So
Okay, so John's. Have you just put a certain?
But that we have to do it now. There is a way of doing it, I will have to look it up. How are the Fusion users doing? You will figure it out now. Okay. And then you have to place it on one row. Yeah, with the middle. If you rotate it, yeah. No, that's good. No, actually, it's on the other side. Now we can go this way. Section between those. You see, he has this menu, the joint menu. This is where you can set some additional options.
Here?
let's have a little break and then we can start again. We're still waiting. Something's wrong back then. We missed the title, so it doesn't matter. So it assumes that you want it to be very common. There's several ways of doing it. Like actually, you can open a part to be like untitled. I would recommend it to not do this like in the very beginning. Show you how to do it. But this might easily get you somewhere where it starts to get very confusing. But now we have this ancient pattern together. So right now you are in the side. And see this parts. And let's say this direction and the other one, right? So if you right click here and say there's a whole figure somewhere in here, so maybe it's here. As long as everything else comes faster, and this happens to if they go here to myself. So now we can see this and this side, control, control, and then now we pass the dimension, so let's do the dimension. Now, there's a button for doing edit more. I guess there's many different ways of doing this. Then you could also make a parameter and assign the value of the parameter to both of the dimensions. Or you could make a whole size and then the pin size, or the other way around. And once you did something like this, it's not something good. So there should be something that indicates that you are having it's called a cellular like flexible or just directly. You see that in the bench line, or this indicates that you have constraints that go from one part to the other. And also very crazy if you're yeah. But mostly if you plan intelligently, it should always work. But sometimes you get unexpected results because and you
I was doing that
Very bad perspective. Yeah, everything around everything.
you wrote the description.
To be set up already. Okay, awesome. Looking forward to it, man.
yeah. But not for keeping the layout short. You should modify for the no? And then the other one.
No, it's not.
Okay. Okay.
I have to go
Then go to the sketch, and then change the sketch. So that the habits are
No, it's 1 hour more. It's just a small part.
fireworks. Okay. Yeah. Well, it's just like a step on the fingers, but we shouldn't do this. I know Okay, so I close everything that I had so far.
So we close everything. Except
Yeah.
So we're going to start again.
Yes.
Okay.
Okay, so I close it. Okay, so I close everything that I had so far. So this is our famous Lego brick. It's not an original Lego brick. The originals, they have written Lego on top. This one doesn't. And I'm taking dimensions. Everybody knows how to use a caliper?
more or less.
Yeah. So this is important, so I'll explain it. So if you like normally for identifying the dimension, you look at where the zero hits your scale. And in this case, like as an engineer, I think in millimeters. This is like think architects think in meters, I think in millimeters. And for most Fab Academy stuff, I would recommend it to start thinking in millimeters. So if you have a sheet of plywood, you know that it's 2,550 millimeters long and 1,250 millimeters wide. It's just like, believe me, it's easier to get used to millimeters than the confusion you will get when you mix up centimeters and decimeters or whatever you think. So for me, if I see 1 here, it means it's 10 millimeters. It's like 10, it's a 10 to thing. And I see that actually it's not, the zero is not exactly hitting the 6 millimeter mark. It's a little bit further, yeah? So it's roughly 10 millimeters. But if you look closely, then I look which one of those, you see the scale here below, that goes from 1 to 0? Right? You see those? Yeah. Or maybe it's easier like you see the 0, this gives like the graph digit. So I count 10, 15, and 1. Let's think a tiny bit more. Now I look which one of those coincides with one of those here. And to me, it seems that the 6 fits perfectly here now. Okay? So now I know it's 15.6. Okay. Yeah. Okay? And we will make it 16. Yeah? And this one, how much is this one?
My math.
I said that you want to make it 30. And so actually, the only dimension, do you know how to use a caliper? Yeah. So the only one that kind of fits here is the 5 millimeter one of this one. And this should fit to the other side now, to those holes. But if I measure those, they're actually a bit less than 5. They're actually 4.8. So that they fit together with a bit of force. We're going to ignore all of this. So if you 3D print this Lego piece, it's not going to work. You will have to like look at the dimensions, and also 3D printing is not always like usually in 3D printing everything is like interior holes are mostly 1/10 of a millimeter too small, and exterior cylinders are normally 1/10 of a millimeter too big. So you have to know a lot of things for making it fit. The best way is to just try it and change it. But since in Solidworks it's very easy to change something, you can just print one or make a test piece, see do they fit, no. So for the moment we just ignore all those point something thingies and we just make it rough. So first thing is make a new file. Okay?
Change the tools, sample,
Okay.
Okay, this is component of you can do components inside inside the bodies. You can create a component of the sketch that is related to a body that is outside the component.
Yeah. This is why it can get confusing. Yeah.
here, right? Yes.
The person working with business is recently someone tells you about open source. What?
Okay, so we click on, like in Fusion, you make a new sketch, and in SolidWorks, you go on Feature, Extrude Boss Space, and Feature. What was Feature in German? And then you click on the middle option, so you can rotate a little bit. And you pick the depth, and you take the even open square.
So I should
Just
do that. Yeah. I've been choosing the wrong one.
Don't worry. Okay, so I go Boss Extrude, top plane, and I draw a rectangle, and this is where the Fusion users can catch up, that coincides with the origin and goes to the top right by 16 and 32. Ah no, sorry, the other way around. I make this one 16 and this one 32. Yeah? And this is for the ones that are already one step ahead, it's 10 millimeters high. Yeah. So 16, 32, and once you leave the 10 that it automatically puts you, and in Fusion you will have to go to extrude and then extrude it 10 millimeters up. Okay. Then I click on the top surface, and they make another extruded boss space. So in Fusion, you would click on Sketch and then select the top surface as your sketching plane. And in SolidWorks, you have to hit Control 8 so it looks on your top. So you have this view. And in Fusion, you can click the. Oh, in Fusion, it does it automatically, no? Yeah. And then I draw a circle, and I put it like in the bottom left corner, somewhere like this. And then I click on Smart Dimension. And I make it 5 millimeters in diameter. And 4 millimeters from the left side and from the bottom.
Is it 4 and 4?
4, 4, and 5. Oh, sorry, this one.
So distance.
Here. Somehow your rectangle is very big.
Yeah, how big should it be?
16 or 32. Okay, everybody has something like this? So you leave the sketch and you make it 1.5 millimeters high. I would recommend you, after leaving the sketch, to rotate your drawing view a little bit, and then you can see what's going on. So it's 1.5 millimeters high. Yeah?
So I have it, but when I
So you leave the sketch?
I kind of
Yeah, I think you're on the next side.
maybe is that inside?
You shut the light off. Yeah, you're on the next side. Yeah, never mind, you just do it on the next side.
Yeah.
So you go then extrude. And both sides this one. This is one. Now we made a cut. No problem. So you can just go here. I don't have to go to the time. There it is, of course. Yeah. So this one, sorry. Say the feature, and you want can just split the directions. No, I'll just say.
As it would be a minus one. Because we are doing this.
So it's minus
Mine. Yeah.
So the next step is going to be a bit more difficult because I don't know how to do it in Fusion. But in Solidworks, you select your feature in the feature tree, and then you click on linear pattern. Can you see this? It's like more or less, it's a bit left from the middle. Yeah? Lineares Muster. You see my mouse?
Yeah.
It's here. Yeah? Yes. Okay, Fusion, I will quickly have to check how to do it. I will explain it in SolidWorks first. So what it wants first is a direction 1. So I make sure that this one is blue, and then I click on the edge, on the long edge. Yeah? And now I see that that next to where the field was just blue, it says edge now. But I can also tell that it's going in the wrong direction, so I click on this little arrow, which flips it to the other side. Can you see how it flips forth and back?
Oh, yeah.
Yeah? So I flip it to this side, and I tell it that the distance is 8, and the number of copies is 4. And then I make a pattern in the other direction as well. So somewhere a bit lower, it says direction 2. maybe you have to click on a little triangle so it opens up. And then direction 2, it also wants an edge. And I choose the smaller edge. And then I also tell it distance is 8 and number is 2. And it might be flipped, so I can flip it from one side to the other. And that's basically it.
Oh, it breaks.
You got a brick?
Yeah.
Yeah.
I got it.
Somebody call it?
Yes. So it's been under create, pattern, and rectangular pattern. Oh my goodness.
Direction. So,
One click is in the distance type, rather than putting extend, click and go for spacing, because that's the spacing. And so, what it does is that it offers you both X and Y axis at the same time. Yeah, that was fine. So then you go to the direction, you select. Yeah, that's fine, that's fine. It won't appear straight away because right now the distance is 0. So they are all in the same spot.
yours feature is
Yeah, so I change the distance about here. Distance again. It should be working, but it's not. Nice.
What is like the second direction?
Space. Oh, sorry. It's fine. The trick is, it is there already. The same with the y-axis.
Yeah.
So you go rather than
Direction Y. Then direction 2 is what? And it's also first dimension, you go back to this one, you right click and sketch. Maybe 4. Actually, there are a lot of things that make working a bit easier. For example, I could just click on a part and it would show its dimension, and I could double click and edit those dimensions. I don't have to go into the sketch and all this. But then you might have to like update. There's like this one in the middle. So and I know all these tricks, but some of them I don't show you because it's just confusing in the beginning. But believe me, there's a lot of ways of accelerating this workflow. Okay, so I have my first pattern finished. And now I want to make it hollow. And for making it hollow, I tell it what face I want to remove. So I click on the bottom face, and then I click on shell, which is in features more or less in the middle. I move my mouse, can you see it? And then I move up here. You see? My mouse is here, and shell is here. And I want a shell of 1.5 millimeters. And this should give us something like this. And then fusion, same thing.
That is so comfortable. It's going to offset and
The cut, yeah. Then you wouldn't get these little ripples in the middle.
yeah.
And imagine you can do something quite complicated and then shell it and save you a lot of work. And as with all the features, you could go back and say, no, I don't want a shell of 1.5, I want it of 1.4. So it's, whatever you do, I could still go back to my very first sketch and say, no, it's not 16 by 32, it's like 16 by 16. And it would just go through all again. Well, suddenly your dimples would like hang in midair, but that's what you told it to do. So yeah. But once you get to the parametrics, you will see that this is a real time saver. Okay, and so now we're missing these little round thingies in the middle. So I click on the inside face of my Lego brick, the one with the little dimples, and I click again on Extruded Space. In Fusion, you make a sketch on the inside face. Control 8. And I draw a circle, and actually most of the time if I know this circle should be more or less here in the middle. But it helps sometimes to I purposely draw it not in the middle, and I'll explain you why. And I draw another circle that is coincident, that has the same, that's concentric. So now I can see my two circles, and I can see that they're definitely not in the middle, which is what I want. And then I make the smart dimension, and I make the outer one 6.5. The outer circle, and the inner circle I make it 5.
Wait, the bigger one I make what?
The dimension of
the dimension of the bigger one is what?
And it's 5. This one is 6.5.
Oh,
It's the outer one. The inner one is 5. Oh, it's really hard to see, eh? And then I make a dimension from the edge of the Lego to the middle of the circles, which is 8. And from the top to the center, which is also 8. Love Lego pieces, they're so simple. Can you see this? This one? Okay, so this one is 5. Oh, there's going to be some other. And this one is. No, this one. This one is 5. Which one's the other one? 5 and 6.5. Then there's another one with 16. Then we can And so once we have this in the right spot, we leave our sketch. And in Fusion, you will have to go to Extrude. And here it already asks us how far we want to extrude it. And so far we did the blind, where we give it a value. We did the through all, which is just going to infinity. And now we're going to use the up to surface, which means go up to a certain thing. But now I have to select the surface that I wanted to reach. So I select this rim around it. And now it's all going to be good. Yeah?
What's the relation between the border and the center of the edge?
Well, actually, I made a drawing for you so I could show you, but it's on my computer, which is in use right now. But for some reason, yesterday VOC kept crashing on me, so I did this like 10 times before I had the video done. So I know all the dimensions by heart now. So I can always make Lego bricks. Yeah.
Find anything anywhere that has the right click and done. And the next thing is that when you put parameters, yeah. This is keyboard plus this dimension. So excited. And you created that later. I have created some little plot incubators. But then that's you can have 2,346 of them should be fine.
Yeah, it's a little asking why.
You can do this. Like, if you couldn't. That reminds me of like the visuals in 3D slides or iteration 1, 2, 3, iteration 2, like, and then suddenly in front of you, you click on that iteration, it will be like 3, 4, 5, 3.
Yeah, we will do this in a moment. Okay? And over here, and this stage, and just okay. Then we do the same. Make sure that you select the last extrude. You select it, and then you do the linear pattern again. And we pick direction 1 is the edge. I flip the direction by clicking on the little thing next to it, and I tell it that it's 8 and just 2. No, 3. Sorry. So distance 8 copies 3. Direction is the long edge.
Wait. That bit, I hit the linear pattern again.
Mm-hmm.
What? Oh, okay. Yeah, and then just
Yeah. Yeah, I guess one with something like this as well. The problem is that the thickness of the tube is not 1.5, it's 1 millimeter. So if you do this, then it might work. No. No, it's the other way. Okay?
What was the distance?
8. Here's the sales presentation.
Right.
But
I don't know.
Yeah, so in Fusion you have to use the pattern on path, and you just use one of the edges as a path. Yeah, if I had known, I would have prepared this for Fusion as well. But it's good. Okay, and here's our finished Lego piece. Da, 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 da. Maybe you want to save this just in case? Yeah. But let's say I want a Lego piece that has like this 3x4. I would have to like start the whole process again, which is not what I want. I want a Lego piece where I just say, you're a Lego piece 3x3, and there it is. And this is where the fun part comes. Is everybody on the same page?
Wait, should I save it?
Yeah, just save it.
The name or?
Yeah, call it Lego 1. I think it's going to be.
SLPP.
Yeah.
RT, right?
Yeah, but you don't have to write this, it's going to put the extension automatically.
Okay.
Yeah, maybe wait a second until these. Right? No? Yeah. So my second job here in Barcelona, you saw the trikes, no? This was my first job. And my second job was working in a company that does so-called family parts for Autodesk Revit. Autodesk Revit is kind of the, I would call it the most modern architecture program. Like AutoCAD, you all know, because AutoCAD is not parametric. Then architects also use Nemetschek from Vectorworks. This is the next biggest architecture program. Then the Foster brothers, they have their own version of CATIA, that is like CATIA for architecture. And then the big player that came about 10 years ago was Revit. And Revit is just like SolidWorks for architecture. So it's in architecture they call it BIM, Building Information Management. So in the end it's a parametric CAD program for making houses. And so if you make a house and you put a window, you take a window that comes from a producer of windows, and those producers normally have windows that are almost the same but come in different sizes. They're all made from the same aluminum profiles, and they're mostly the same apart from the sizes you can choose from. And so what you do is you make what they call a family table. So you have kind of like an Excel sheet that says, this one is this wide and this long and this deep and blah, 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 blah. And this one is all the same, but it's this long and this wide and blah, 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 blah. And so you make a CAD model that connects to this table. And whenever you change the line in the table, your window changes size. And in a house, almost anything comes from such a family table. So for example, we made all the IKEA pieces, which are not so flexible. Most of them you can only choose like, you have the, I don't know, I forgot all the IKEA names already. It's more obvious for stuff like sprinklers and climatization, lights, chairs, tables. Like you can go and say, oh, I want the IKEA table 80 by 120, or the 180 by 110, or I want the climatization unit 10 kilowatts with these dimensions. Like we had everything in there up to the computers to control your house. It can get quite advanced. And so my company's business was to create these family parts that would then be bought by somebody that wants to build a house in Revit. And this is kind of what we're doing right now. We're making a Lego part that is parametric, like we're making a Lego family. And in this case, our family is going to have any number of rows and columns that we want. And for getting there, we have to define two parameters, which is rows and columns. So if you go to Tools, there is something that is called equations. And in Fusion, maybe you just try to find it. If not, I'll try to find it with you in a second. Tools, equations.
So under modify, there's change parameters.
And then we make one parameter, which is called columns. So I click here, global variables, and I call it columns. And I just hit enter.
And units?
Then you click on the global variables. And I give it a value of 2. Enter. And then I make a second one, which is rows. You could call it any way you want to. And I make it 4. That's it.
You said 4.
Yeah. Somebody found it?
Yeah.
Yes. Yes, that's it.
And then you said that the expression is 2. Yeah? No, you said that.
So unit is no unit.
Yeah?
Value is 2.
Aha. Okay, so expression.
This could be a formula. You could say, like what I said about the Tetra Pak, you could put a formula that always makes it so that you need the least amount of material for the, like, yeah, you can get quite advanced with those things. Okay. Everybody's on the same page?
So we did like columns.
Yeah, you create 2 user parameters, one rows and one columns.
And rows also.
Yeah.
So that's to change the
Yes.
Yes.
was that?
Can you add something to like allow for like L-shaped pieces and stuff like that? Can you define like a hole on the sides, for example, and then like change the size of that hole so you have.
Yeah, you can, like you will see in a moment that you can change anything you want. Like,
So you put 4 rows and 4 columns and the hole is like 2 by 2.
Yeah.
Then you could have like an L-shape.
Yeah.
So like for this, you would just, it would be like, here it would be like 4 by 4, but like the hole would be 2 by 2, so 2 by 4, so it would like.
Yeah, maybe let's just continue on this one and then you see.
We have to add value.
Okay.
And then the castle will be
Okay. So I want you to go back to the sketch of the very first rectangle we did. I go to Edit Sketch. In Fusion, you just have to you have to go in the timeline to the place where you drew the thing.
We need the first face.
Yeah.
Is it this one?
And in SolidWorks, yeah, this is one. Control A.
Yeah.
Okay, and now I take I click on the 16. I double click on my dimension, and now I will have to check how this works in Fusion. And now it says 16 millimeters. But instead of that, I will write an equal sign, and it will open my drop-down where I can see my global variables. And I pick my rows, I just click on it, and then I write multiply by 8. And since 2 times 8 is 16, it's not going to change anything. Oh no, wait. I thought rows is 2, no? No, I have to choose columns, sorry. Yeah, columns times 8 is the one, and rows times 8 is the other. And you can see that now it puts like a little sum sign in front of the dimension, and so you can't manually edit it anymore once you do this. Okay? Let's see on the first.
No, you just start typing and it offers you a choice of variables.
So we should choose columns or rows.
Yes. Okay.
Wait, can you repeat this?
And then times 8.
Oh, here.
And now you write times, which is this.
Okay.
The other one is times. This is the other one, times 8.
Yeah, this is
So this is rows or columns?
I think each there you should use
Oh, you replied and wait. You should have. That's wrong.
Thank you.
so
You can,
these are going to be rows.
Let's go back to the formulas and make them make it 2 and 4. Yeah, each piece is like 8. So, yeah.
And here, it's like columns.
Also,
Yeah,
by
but
8.
it's the same.
Yeah.
Now you would put if you change the parity, I think the thing is that you would see the change would be better if you would add the variables that are a bit different from the original design.
Take your time. So now we have the same variables. Like if you let's go step by step. If you you will see in a moment why I'm doing it like this.
Okay.
So now we have the 2 formulas, and I leave my sketch, and you can see that also here in the tree there's like a drop-down equations now, which is kind of quicker. If I click on this one, manage equations, it's just a quicker way of getting to the same menu. You saw it? You see my mouse? Here's my mouse, and here's equations, Gleichungen in German. She's using my computer. Okay? But you can also just go through the menu. And so now I changed the 2 to a 3. Enter. Okay. And so now you see, okay, this messed it up a little bit, but it's still not broken. So what happens quite often in those programs is that something goes wrong and it suddenly is red and it screams and gives you lots of dialog boxes that say you did it wrong, it's all broken. You can mostly just ignore them and then think a little bit why it broke. Like typical example is you have like a block that is like 3 millimeters thick, and you make a round that is 1 millimeter. Perfect. But now you make a round that is 2 millimeters, which doesn't work. Like you can't put like a 2 millimeter round on or two 2 millimeter rounds on a 3 millimeter material. It's gonna crash because there's not, yeah. But in the end, all you have to do is go back and change it back to like 1 millimeter or 1.5, and then all your arrows will suddenly disappear. So having to deal with stuff that goes red and crashes and complains is completely normal. That's what 80% of the time you spend doing computer-aided design is fixing errors, believe me. If you're very clever and you build your stuff looking ahead very far, then you might end up doing designs without errors, but usually what you do is fix errors. So for example, building a cylinder head, I spent 2 years fixing errors. Or maybe of those 2 years, I spent like 10 to 20% of the time actually adding new features. The rest of the time I would just like get them. Somebody tells me, no, this one has to be a millimeter over here. So I change it, but then something crashes and I have to fix it all, and then this is your job. Not very exciting, but you get the satisfaction of if you build it very clever, if your formulas are very good, then it will take care of all of those possible problems. So you can put a lot of thought in there, which can drive you crazy, like, or you can decide, like, actually the interesting part is at which point you decide to consciously disconnect it, so that the formulas don't go all the way through, but they stop at some point, where you can recheck everything, and then it continues. But yeah, that's another discussion. Okay, so now we have to fix our pattern features. First, this one. So I go to the first linear pattern. I edit the feature, and I see the second direction should be not 2 but 3. So I click here where it says 2, and I put my equal sign, and I pick my global variable, which is columns, which is 3. And I do the same for the 4, only that I pick my global variable rows. Yeah? You got it? See you in red. This is our and then here, where it says 2, I write equals to the first column. And I take my global variable, which is columns. Yeah. And in this one, where it says 4, you put arrow. Does this work similar in Fusion? Yes. Yeah? Okay. And so now we only have to fix like the bottom thingies.
Yeah.
So I go to my second linear pattern, and I edit it. And the Fusion users, they will have to delete the pattern and make a new pattern that has like 2 directions.
Ah, okay, so not linear.
Not on path, but linear.
Yeah.
Yeah. And so first of all, I add a second direction, which we didn't have before. So I click on direction 2, and I choose the second edge, the short one. And I tell it that the distance is 8, and that my parameter is columns minus 1. Okay? So now we have to start putting formulas, because it's not the number of columns, but it's always 1 less than the number of columns. So it's columns and minus 1, and I hit enter. And I have to flip the direction. And in the other one, I delete the 3 and I make it into rows minus 1, enter. And this should be it. And but repetition, I have to put this Fusion is different.
So then you replace the color. So this is column per. No, it has sense, for example. Okay, which is the.
That's the problem.
So.
Okay, and I think by now you already guessed it. Now I can go into my equations, and if I change the parameters for rows and columns, I can make it 5 by 10. I get a Lego piece that is quite big.
I wish you could.
Like the model still has one column. And
Okay, so basically, okay, so
the direction
so basically, it's not a straight this one, force. And then here instead of this,
It's because you gave your records in the inside. And this is called as minus one. So there's something else here. It's going to change now when they're we're just trying to work so I think you can't update on okay, right? Okay, right. So if it doesn't work, just create another one. Oh, yes, I think you did it triple. So maybe later that you want to
Yeah, it's automatically
But you asked me about the show and where you were telling me that no units. That thing.
No,
No,
yeah,
you
yeah.
have no units because
I
she's
think we just have normal, so it's
Rules, yeah. So no plans, but no beans. There is no beans option at the top.
what's wrong with it?
Just give that.
You know better.
I could have been there, okay. Oh, it could be.
Before.
Awesome, and now try to get it in there.
No, it's
Just put it here, put it here.
I would go back.
Or
Go to the it's in 2 and 4. So this is 2 and the other one is 4.
so that one is one more.
Yeah. Okay. And no, there's nothing wrong because the length is more than it should be. Maybe if you go back to the first sketch.
That's fine.
Okay, so now I have to change also the scale.
That's interesting.
And I got the first one.
Now they're both 32.
They're both 52 now.
Rows. Oh, sorry.
Yeah, you know, those times.
One is no, it's times 8 instead. I know it's okay. Let me see a 16 by 16 Lego brick.
Yes, no problem.
And has somebody found a problem already with this model?
Yeah.
Have you tried a 1 by 1 brick?
Yeah.
It crashes.
It's not a 1 by 1. It's a 2 by 2 from the upstairs one, and then since the one inside is only one, it says kind of like.
Yeah. So for getting rid of this, you would have to use an if condition. So in the formula, you would, instead of writing equals columns times 8, you would write if, and then columns smaller and bigger than 1 is that, and if it's smaller than 1, it's that. And you would just tell it, okay, if it's too small, just don't make it, don't do it in the middle.
Could you please tell me what it is? Because it's doing the same stuff.
So very nice. So now it's ready.
Yeah, you should go first. Without trying.
Yeah.
So now we can go to the second knowledge info. This one's.
So here it should be this, right?
This is going to be 2. This is 2. Yes, 2, 2. No, that's 1. 1.
These stupid things are cute. So I think I'm going to change the name. So we are parametric. We are looking at parametric like environment, but when we define things forever, but the rest.
Is there anything on
As soon as you put more, it's okay, no?
Yeah, this is because there everything else.
I think this one I was but if you make a 1 by 1, everything has one.
Yeah, because the second chapter doesn't exist at all.
Yeah.
So
And so I would go in here. And here. So, yeah, I just delete this for a second, so you can, if you're ready for. And then here we get all the functions. This is our sine. Stuff. You see the
If you see
oh, okay.
insert parameter.
Yeah, so it's like this. And then bigger one.
So,
Yeah.
it's because
No bigger than the budget. No bigger than 2, actually.
this is wrong.
You read something else? No? So,
Currently, you import CSV.
yeah,
Change that.
then you write the simulations. And then what happens if it's true? And then what happens if it's false? So this is kind of
If it's not, then this is wrong.
so here it says that if length is bigger than 2, like this. Otherwise,
You can just enter the value in millimeters and it will work. So if it's got millimeters, you enter 10 millimeters, it will work.
but I would just
There's a possible leaders.
have them also, it's in the part.
Yeah, and now check like so
No, it doesn't. It should be a feature.
so then this surface, if you want the surface, because you background. Yeah. For me, I
This is like a surface offset, and you want to be we have 15 minutes working on that. No. Yeah.
because
Okay.
our road
Yes.
so you have to
Oh, okay, so we should make a
Well, just kind of thing.
like
Yeah.
okay.
Yeah, sorry.
I can put it in Solidworks, so I can in Fusion, so I can
Yeah. You have to like change your. Did you change the dimensions of the drawing?
This is basically cheating for you. Like suddenly you know just rule and you can create these things.
Okay, give it a try. Maybe change one.
Definitely.
Okay. Okay. Yeah, you're almost there. Okay, I hope this was somehow helpful.
Yeah, it's
I didn't put you my email. Like my email is ferdi@fablab.bcn.
Put it here because then it's gonna be recorded. So.
Should we stop the recording?
Well, I mean, everybody will have your email.
Yeah, I don't care.
Yeah. It's nice.
Okay, feel free to write me an email, or I'm always here 2 times a week, and I'm happy to help.
Sure.
Amazing, amazing.